Hello, my name is Shimon, and I want to present you my paper, Dynamic and Evolving Neural Network for Event Discrimination. First, I want to present my AGI model very briefly, just an architecture. It is inspired by a neural model of Jeff Hawkins from his first book. Here we see a side view sketch of the model and its top view diagram. As you can see, it is a hierarchical structure with some supervisor program that supervises the whole AGI, and the working memory below, which fuses two modes, the visual and the auditory modes, and each of them has its own processing unit that translates the inputs, the sensory inputs, to its unique memory. Now some AGI details. This AGI model is based on global working theory, since here it is also based on multiple agents or components. Additionally, one-dimensional information such as language has a shared memory for input, output, and working memory, denoted as 1D memory. This is also true for the multi-dimensional information. It is also based on stimulus-response behavioral theory, which states that the mind can be communicated with, although unobservable. This is why the black box. We have a stimulus and black box, and then response. The AGI itself should be adapting itself to the environment, meaning to be dynamic. Hence, it should interpret spatial-temporal objects or events. Object recognition or tracking or even scene understanding, like here, are all treated as frame-separated philosophy, while AGI should interpret events continuously, not as fragments. Hence, the deep learning model we propose is based on events as a whole, without separating the space from time, just like in the relativity theory of Einstein. In my earlier model, I thought that as we have two channels of input, vision and language, similarly, we can extend the design for AI to have these two channels also as outputs, so that we can see its inner thoughts. Then I wondered, why don't we humans have imaginary tool as output? One can argue it would hurt our basic desire for privacy. But then, as we choose whether to talk or not to talk, we can similarly choose when to turn this tool on and when to turn it off. My current opinion is that the world we see with our eyes is what we all agree upon. Other than that, our inner models of the world are totally different. And why we don't have symbolic or linguistic channel also objective as vision? Why we end up with inner individual and unique symbolic representation? I think it's because language is highly context dependent, and since each person has different contexts along his life or different experiences, then it develops in different meaning or different feeling or understanding of the objective concepts we are all agree upon. Concepts of a language that we use to communicate with each other. So the concepts we use in external communication are objective and common to all people, but their interpretation is different for each of us, depending on the specific sequence of experiences each one goes through. Therefore, physical reality is only for objective agreement for effective communication between us, which realized via language. However, vision is not a communicative channel for us. Now we present our DNN model. We know the regular DNNs used for special object tests, such as clustering or classification. But what if we want to detect and extract features also along the temporal dimension? Then we simply extend the DNN to include this dimension without changing the spatial dimension, meaning orthogonal to it or perpendicular to it. So in the following, the DNN we will see is spatial-temporal one. We can see here only the temporal dimension, and here we see both of them. Now we present some assumptions about our DNA. First, we assume that the task is to identify events. Secondly, we assume that small amount of data should be represented by a small model. And similarly, big data should be represented by a large model. We can see here an example from a paper showing that performance is a function of the data. Also, by gradualism, we mean that we assume that the AGI generally, or in this case, our DNN specifically, should be growing along with its experience with the world. It should grow internally. And following that, the complexity it encounters should also grow accordingly. The growing itself should be based on experiences, meaning it is embedded in the perceiving experiences of the DNA. In other words, in the visitations over neurons and weights. For example, by counting these visitations or occurrences. Based on these assumptions, we propose our evolving DNA, demonstrating it like a newborn infant perceiving its environment. But before we start, we just want to mention that we assume that the DNN is perceiving and updating its weights according to the deep learning methodology, meaning a feed-forward perception and backpropagating weight adaptation. Only the difference is that in addition, we assume an external supervising algorithm that controls the changes in the DNN architectures, its structure. Now, the first thing we assume about an infant is that it learns unsupervised. He starts with a single event detection, as we can see here. Also, as you can see, we assume some initial deep neural network. So it doesn't start from an empty network. It has some initial structure. Now it can differentiate two events using the deep features in between. For example, day and night. And he can go on and recognize as many events as necessary. It is adaptive neural network structure, adaptive by necessity. At some point where strong connections and event identification is strengthened, it can move its attention to other stuff, or its sources are more free since the given level is more automatic for him. It can build a new floor if reoccurrence of events is detected. Thus, it is actually hierarchical multitask DNA. The composition, as you can see here, can be either a sequence of events or not a sequence. An opposite structure changing operation can be decomposing of an event, if it appears to be more complex than it was supposed to. Here we recognize that the ball in the air event is a composite event. So we decompose it to a simpler events. We can view it as a refinement. Additional information you can see in the paper. Some issues with the model, advantages, and related work coming from many fields in AI, such as continuous or lifelong learning, unsupervised learning, event detection, network architecture search, and growing networks. Thank you for listening.